When someone has pulmonary arterial hypertension, or PAH, their heart and lungs undergo structural changes which leads to increasing pressure within the pulmonary circulation. Let's take a closer look at how this develops. First, we'll focus on how blood flows through a healthy heart and lungs. The heart contains a left and a right ventricle. Both have the same responsibility, which is to contract and move blood forward. However, one ventricle requires much more strength than the other. Let's find out why. The right ventricle is lean and agile, built similar to an ice skater, and designed to pump blood into the low-pressure system of the lungs. Although the ice skater has an important job, he does not require a lot of strength. In contrast, the left ventricle is thick and muscular, similar to a bodybuilder, and built to pump blood out into the high-pressure system of the rest of the body, therefore requiring much more strength. Even though they have the same function, their strength requirements are very different. Let's get to know a little bit more about how the right side works. Two veins, the inferior and superior vena cava, feed blood into the right atrium, where it passes into the right ventricle. Each time the lean ice skater right ventricle squeezes or contracts, blood is pushed through the pulmonary artery into the low-pressure system of the lungs. An example of a normal pressure in the pulmonary circuit is 25/10 millimeters of mercury, with a mean pressure of 12 millimeters of mercury. The newly oxygenated blood travels from the lungs to the left atrium and into the left ventricle, the strong, sturdy bodybuilder, which then pumps blood out into the high-pressure system to the rest of the body, also known as the systemic circulation. An example of a normal systemic pressure is approximately 120/80 millimeters of mercury. In a healthy individual, the right ventricle and the left ventricle work together in harmony. Now let's see what happens in someone who develops PAH. We'll need to look closely at the pulmonary circulation because this is where PAH begins. PAH is defined as a mean arterial pressure greater than 25 millimeters of mercury, with a pulmonary capillary wedge pressure less than 15 millimeters of mercury. The pulmonary artery is affected by this increased pressure. However, the actual dysfunction begins in the pulmonary microcirculation. As the right ventricle contracts, blood flows through the pulmonary artery into the smaller and even smaller vessels called the arterioles, which eventually lead to the microscopic capillary beds within the pulmonary system. It is in the smaller arterioles where the dysfunction occurs. These tiny vessels may become partially occluded or completely blocked, progressively increasing the pressure within the pulmonary space and reducing the amount of blood that reaches the lungs. With the steadily increasing pressure within the pulmonary artery, the right ventricle is presented with a continuously increasing workload. The earnest right ventricle tries to keep up by building muscle and increasing in size and strength, but even with intensified efforts to accommodate, sadly, he was never built for the job. Despite his diligent efforts, without medical intervention, the exhausted ice skater, representing the right ventricle, eventually wears out, leading to right heart failure.